Good morning, everyone. I'm Pushpesh Singh. I'm working as a project manager in IIT projects. And right now, as we know, we are actually very behind the schedule, so I'll keep it very simple and short. I'll be speaking more about the groundwork we have done in the classroom projects related to how we have installed the multiple sensors in the classroom and how we are monitoring the data. So So this is the introduction part where you can see that our aim is to, the idea was make the classroom more adaptable to people rather than making people adaptable to the classroom. So idea starts at we'll start monitoring and also enhance the indoor air quality, as you can see. Sorry. By leveraging the combinations of using environmental sensors such as CO2, PM, VOCs, temperature and humidity, and doing real-time data analytics using automated control systems. So we want to make a kind of model which can be scalable, apart from, let's say, how Professor Krishnendu Sinha told you about the different classroom we have been aiming for different occupancy levels, and also focus on health comfort of students and faculty. The objective, as I've mentioned earlier, real-time monitoring to track CO2, particulate matter, temperature and humidity. Data-driven interventions to utilize CFD and live data to inform and optimize ventilation strategies in real-time environment, and to focus on health and energy savings. These are the IoT devices which Professor Sinha also showed you earlier. So this is how they are working. This is the AQM end devices which are in-house made, and they have off-shelf sensors. The AQM end devices are putting data into the AQM gateway through LoRa network, and they are sending data to the IITB servers through IITB Wi-Fi, which are internal network. We have done some co-location studies for the validation of these devices with the scientific sensors, what Professor Srinidhi ma'am has explained about the Lutron sensor, which are scientific grade. So we have done some co-location study, and we find that they are particularly seamless, working fine. This is the multi-point sensor placement we have done in LT classroom, which already have shown by Professor Sinha, that how we are doing multiple sensor placement in LT 303, which is 60 occupants seater, LC classroom, which are 150 occupants, and ES classroom, which are 80 to 100. So here you can see the layout of the classroom, which has 4 ceiling fans, and these boxes are somewhere where we have, with CFD driven analysis, we found that these are the best placement for the sensors, and we have placed those sensors here, you can see on the red marked area. So these are also done with the help of calculations we have done for the keeping in mind the ACH of the room, and also the flow dynamics, where the interventions are placed, and also the practical constraints for the installation. This is the LC classroom, a 150 seater classroom, a classroom like this, where we have around 10 sensors placed inside, 1 sensor outside to know the ambient values. And this is the 3D diagram of it. And here you can see how we have placed the sensor at the ceiling height. This is ES classroom. So the difference between the LT and LC and ES classrooms are, ES classroom have centralized AC systems. So here there is a challenge where we need to see the flow dynamics coming through the ACs, cassette ACs and lowers above. And then define that, you can see here the sensors are very far from the cassette ACs. Yeah. So the idea for placing the sensors was, as Professor Sinha also mentioned, and Professor Rajneesh mentioned about how we are doing sensor placement. So there are a lot of interventions in the classroom. If you'll have ceiling fan, exhaust fans. So we have done a simulation for different combinations of, let's say, 45 to 60 cases, where we found that, okay, these are the optimal placement for the sensors on the basis of the simulations done through CFD. Similarly, we are doing for LC and ES classroom, where we can find the optimum placement of sensors. Now I have explained about that how we are getting the data from gateway to server. This is a dashboard which we are receiving the data. Here you can see that this is a dashboard for the LT classroom, where we are getting real-time data which showcase the humidity, temperature, PM, CO2. Here are the number of devices here, and the data is coming. These are the timestamps, and real-time data is coming. This is the show about how we are able to see the data in real time. So somehow it happens ki when we see some spike in the CO2, we usually go and see. Right now, the automation part, we are working on it. We see that what is happening. So we see that in LT classroom, if there are around half of the, let's say, occupants, then also CO2 rises very high. So it's as an indicator, as Professor Srinidhi mentioned, that it can be an indicator of high infection area. Yeah. So this model already explained by Professor Srinidhi about the mass balance equations, how we are doing it, and our model which we have created and we have compared it with the experimental model, it is somehow like in terms of what you can see here, it is matching well. These are the model experiment we have validated through ACH. So you know ACH is Q by V, and this is the calculation of ACH. We see that the real-time data and the model data are matching well, and now we can use that model data to use in our algorithm to automate the ventilation. Okay. Yeah. So this is the idea behind the dynamic control which we are doing. Professor Srinidhi already explained about it, the rebreathe fraction, the critical rebreathe fraction, and the infection probability. Now we are trying to utilize these parameters to control the real-time dynamic ventilation. So this is the summary of what I have given. So we are actually by combining sensor, network, real-time data, and processing, the system ensures that classroom remain healthy, energy efficient, and infection resilient. So idea is here ki we'll be doing deploying the algorithm for the real-time control. We wanted to measure energy using Professor Anupama's help, and also using other ventilation interventions like air purifier. We have Daikin team here who can help us out in this for the air purifiers, and also expand the finding across additional classrooms. So we want to scale it. We want to scale it from LT, let's say, which is a 60-seater classroom, to bigger classroom, let's say a classroom like this. So that's it from my side. Thank you.